So we've been dealing in these lessons with slopes, and we've looked at how to calculate a slope from a couple of points. We looked at putting an equation in a slope-intercept form and finding the slope. If we have it in that form, the slope is the coefficient of the x term in that equation. We looked last time at parallel lines. Parallel lines are lines that have the same slope. Today, this lesson, we're going to look at lines that intersect and are perpendicular to each other. Perpendicular lines have the negative, a perpendicular line. First of all, let's explain what a perpendicular line is. Perpendicular lines are lines that form right angles when they intersect. A right angle is a 90-degree angle, and the symbol is a little box like that. That means this angle is 90 degrees. This is called a right angle. So lines that intersect at 90 degrees and have right angles are called perpendicular lines. These two lines are perpendicular. So the slopes of perpendicular lines are the negative reciprocal of each other. A negative reciprocal. The slopes of parallel lines are negative reciprocals of each other. Well, what's a negative reciprocal? Think of it like this. If we have, I'll just pull a number 3, and we want to multiply it by a number x to equal 1, this would be, x would be the reciprocal. So what number times 3 would equal 1? Well, 3 times 1/3 equals 1. So the reciprocal of 3 is 1/3, and the reciprocal of 1/3 is 3. That's what a reciprocal is. A negative reciprocal would mean we'd multiply 3 by a number x that would give us a -1. Well, what would x have to be to give us a -1 if we multiplied it by 3? It would have to be a -1/3. So a -1/3 is the negative reciprocal of 3, or 3 is the negative reciprocal of a -1/3. Either way. These negative reciprocals, these slopes, lines with slopes of 3 and a -1/3 would intercept. If you had a line that had a slope of 3 and another line that had a slope of a -1/3, those lines would intersect. Let's look at this. Let's do a problem, example 9 in your text. It asks us, on the same set of coordinate axes, sketch the graphs y equals 5x plus 2 and y equals a -1/5 x minus 4. Now, the 2 and the -4, they don't make any difference as far as the lines being perpendicular to each other. Those are just the points where they cross the axis. But we recognize that this has a slope of 5 and this has a slope of a -1/5. These are negative reciprocals of each other. So because they're negative reciprocals, when we graph these two lines, they should intercept and they should be perpendicular to each other. And let's graph them and see. Notice these are already in our point-intercept form, so we don't have to manipulate the equation any to get it into the right form. So we'll draw our coordinate system here. And I'll count each one as a half. Each of these little increments is 1/2 of 1 unit. So each of these little hash marks equals 1 unit. All right, and we go 1, 2, 3, 4, 5, and a -1, -2, -3, -4, -5, and 1, 2, 3, 4, 5, 3, -4, -5. We label our axis. This is y, and this is x, and this is 0. Our first equation was y equals 5x plus 2. Our slope equals 5, which is 5 over 1, which is the change in y divided by the change in x. Our intercept is 2. So we know this is where this line crosses the y-axis at 2. Our slope is 5 over 1, so we go up 5, 1, 2, 3, 4, 5, and we go over 1 in the x, so that would be right here. This is our point. Or we could go negative and negative. That's still a positive, right? Excuse me, a -5 divided by a -1 is a positive. If we went negative, we'd go down 5. 1, 2, 3, 4, 5. And we'd go a -1 direction. Negative over a negative, which would give us a point right here. And notice if we connect the points, these 2 points, excuse me, and these 2 points, we end up with a straight line. So that's this line. That's the graph of this line. Y equals 5x plus 2 generates this line, this graph. Now we'll graph a line that has a slope that's a reciprocal of this. And the line was y equals a -1/5 x minus 4. So our intercept is going to be a -4. That's right here. Let me extend these lines. These lines now can be extended to infinity. And all the points that you can plug in for x and generate y, all of those ordered pairs will be located on this line. All right. So we have our second equation, and we found the intercept. Now the slope. The slope here is a -1/5, which is the change in y divided by the change in x. And that can either be a -1/5, or it can be 1 over a -5. Doesn't matter where we put the negative. It's either going to be a -1/5 or a +1 over a -5. Let's do it both ways. Doing it both ways should give us points on the same line. So we'll start here. That's our intercept. Our -4 was our intercept. And we'll go in the y direction a -1, down 1. And 5, a +5 in the x. 1, 2, 3, 4, right here. That's a point on that line. Or we could go a positive 1. Here's where we intercept. We'll go a positive 1 and a negative 5 on the x. 1, 2, 3. Let's see. Positive 1 and then 1, 2, 3, 4, 5 right here. So this would be our second point, our third point, I guess. We have the intercept, we have the point here and the point here, and we can connect these lines. And when we connect these lines, we have a line that intersects our first line, and this angle is 90 degrees. That's a right angle. This angle is 90 degrees. So when we have two lines, like here and here, and the slopes are negative reciprocals of each other, we'll generate lines that intersect and form right angles when they intersect. Okay? That's the end of this problem.